Hi, we are back with another video on the topic What is Docker? Before we deep dive, please make sure you subscribe to Scala's YouTube channel and don't forget to turn on the bell notification icon. If you have any doubts, feel free to drop a comment below. In this Docker session, we aim to help you learn everything step by step from basic to an advanced level. The major topics to be covered in this session include history before containerization, reasons to use containers, a quick introduction to Docker, etc. We will try to answer all about the containerization, working of Dockers, and its architecture. What is Docker? Docker is the collaboration of multiple platform as a service PaaS applications under one roof that is available to all users. It uses operating system level virtualization to offer the benefits of cloud technology to different companies. The different containers in Docker can communicate with each other with predefined channels. Valuing the necessity and requirements of Docker in modern age coding, we have prepared this session on Docker to offer all required details to you. Before you start our informative session on Docker, please subscribe to our channel to get the latest updates of different content. Let us start our information tour on Docker now. All the leading programmers globally opt for Docker-based containerization to create high-end applications. It optimizes the power of virtualization to bring the best out of development and deployment. Docker comes as an improvement to cloud development and makes the work of developers quick and efficient. While organizations are migrating to cloud technology, Docker comes in handy. It is further created to enhance the native Linux containerization. This video will help both beginners and experts to understand Docker. It has something for everyone. History before containerization. Containers have evolved over the last 2 decades. The modern VM is credited with special purposes like installing multiple OSs on a single machine that is enabled to hold multiple applications. The entire container-style process isolation began by restricting the application's file access to the specific directory. Before jumping to the amazing world of Docker, it is crucial to understand the history before containerization. There were multiple developments in the software industry aimed to ease the life of the developers. CRUDs and jails were popular technologies before containerization. Free BSD jails were introduced in 2000 as an extended version of CRUD, which was first developed in 1979. The CG groups were introduced in 2008 in isolated resource usages such as CPU, network, disk, and memory. Linux namespaces same as an improvement to CG groups in 2013. Cloud Foundry and Warden then introduced LXC under the hood in 2011. Google developed Let Me Contain That For You or LMCT5 as open source tools in 2013, and Docker was introduced by Docker Incorporation in 2013 as well. With their specific features like alert technology, logging, and necessary monitoring, cloud-managed containers created an active space for modern organizations. Containers promise an array of benefits of microservices that were impossible with the traditional technologies. The development of orchestral tools like Kubernetes helped establish fully contained and scaled applications. This evolution of container technology is still in process with the advancement in artificial intelligence. What is containerization? Containerization is an emerging trend in software development. It encapsulates software code and all dependencies to run uniform and consistent applications using different infrastructures. Thus, containerization is a trusted technology that is used to create and deploy applications. Hence, it allows all applications to be written once and run from any corner of the world. Containerization can be easily understood with the concept of containers in shipyards. Containers are a shield to keep the items until they reach their destination. Containers in IT are used to store configuration files, dependencies, libraries, etc. Containers are well known for the storage and deployment for different applications comprehensively. Modern ecosystems like Docker, Kubernetes, etc. enable containers to work in complete isolation from other containers. Top reasons to use containers. Many IT companies trust containers for the following reasons. First, prospective hires. Companies using containers can attract the best IT talent available in the market. Second, manageable learning curve. An IT workforce with a container paradigm can manage the learning curve easily for quick migration to cloud technology. Third, flexible deployment. Containers are free from any type of server or programming frameworks. Thus, different applications can be quickly deployed using Docker. Fourth, using existing infrastructure. There is no need to buy new servers and new cloud migration as containers work with the pre-existing infrastructure. This further optimizes the existing hardware usage. Fifth, open source. Containers reduce acquisition costs and eliminate the cases of vendor logins. Sixth, quick deployment. Containers are perfect hosting platforms for continuous delivery pipelines. Seventh, consistent functions. Containers make testing, staging, and deployment consistent, thereby ensuring stability. Stay with us to learn more about Docker, its features, and how to use it effectively. Introduction to Docker. Docker is an open source platform that is ideal for developing, managing, and running applications. Using Docker, it is easy to separate your applications from the infrastructure in order to generate profitable outputs. Docker combines kernel containerization features with tools and workflows to deploy and manage different applications. It runs in the Kubernetes engine with ease. Docker helps developers separate the applications from the infrastructure to manage different applications. It allows the packageability and application running in the loosely isolated environment called containers. It provides tooling and a dedicated platform to different developers to manage container lifecycle. Keeping all these things in our mind, the next part of the video is tailor-made for you. How does Docker work? To understand the working of Docker, it is important to know about its components. These are as follows. First, Docker daemon, Dockered. It is responsible for all the actions related to the containers. It receives commands from the Docker clients using REST API or CLI. Second, Docker client. It can be on the same host as that of the Docker daemon or can be present on other hosts. Third, Docker images. Docker images are the building blocks of Docker. Images are required to run containers in Docker. These images contain tools, dependencies, operating system libraries, etc. that are necessary to run applications. Fourth, Docker registry. It is the repository for all Docker images. It allows developers to share images and can be public or private. Docker Hub is the hosted registry service of Docker Incorporation. Fifth, Docker containers. They provide the execution environment for Docker. Thus, containers are the writable layer of the images. Now have a look at some Docker fundamentals and what it is used for. What is Docker used for? While understanding Docker, it is often misunderstood as a container. The first container-related technology was available for years, while Docker was released to the public only in 2013. Multiple developers used Docker to first create lightweight and granular updates. Linux containers, that is LXC, require multiple processes, while Docker containers can use a single process. Thus, applications can continue running even while updating. Second, track container version. Docker tracks container version, roll back to previous versions, and can trace the manufacturer of the version. Third, shared container libraries. Docker helps developers quickly access the open source registry that comes with user contributed containers. Fourth, improved and uninterrupted portability. Linux containers, that is LXC, require machine-specific configurations, while the Docker container runs on multiple environments without any modifications. Fifth, automated container creation. Docker builds application source code automatically. Sixth, container reuse. Existing containers can be used to create thousands of user-contributed containers. Features of Docker. Let us briefly discuss the top and best features of Docker that include but are not limited to the following. First, application isolation. The applications created using Docker run in an isolated environment. Thus, Docker can execute all types of applications as every single one is independent. Second, swarming. Swarm is the scheduling and clustering tool in Docker containers. It enables pluggable backends and is a popular self-organizing engine group. It uses Docker API to use various tools at the front end. Third, security management. Docker saves secrets into the swarms with allowable access to different users. The different commands used are secret, create, secret inspect, etc. Fourth, improved software delivery. Software delivery becomes efficient with Docker. The self-contained, isolated disk volume and portable containers can be easily deployed to different environments. Fifth, ability to reduce the size. Docker can reduce the size of the development as it offers a small operating system footprint. Sixth, quick and easy integration. Docker has quick and easy integration. It makes it easy to deploy codes with fewer efforts in less time. Further, Docker can be used in a variety of environments. Seventh, increase in productivity. Docker eases the technical configuration and quickly deploys multiple applications. Thus, Docker increases productivity and reduces the resources requirements. Eighth, list of tasks. Services are the list of tasks in Docker. Every task in the services list has one instance of the container that is running. Ninth, rapid scaling of systems. Containers don't require dedicated computing hardware and allow data center operations to accommodate more workload in less hardware while sharing existing hardware. 10th, software-defined networking. Docker CLI and engines enable operators to define isolated networks for assigning containers without touching the router. The software-defined networking allows multiple developers to design systems with complex network topologies. Let us start with the advantages and disadvantages of using Docker. First, advantages of using Docker. The dedicated use of cloud technology is not the only benefit of using Docker. There are multiple other advantages of using Docker that include but are not limited to the following. First, quick deployment with cost effectiveness. Docker-powered containers can be deployed quickly without any lags. The process of deployment can be shared with the new apps and hence there are no extra overheads or work. Second, repeatability with quick automation. The entire coding development speeds up as the process is built using repeatable codes and configurations. The simple maintenance with automated features allows quick speeds at all times. Third, flexible. Docker is flexible and allows different developers to build, test, and release different images using multiple servers. So, whether it is an upgrade during the product release cycle or accumulating a new security patch, Docker remains flexible to all users. Fourth, isolated and consistent environment. The predictable environments created by Docker are isolated from different apps. The increased levels of productivity are credited to more time in launching fresh features and less time in debugging. Fifth, highly mobile. Docker containers can be run anywhere like on Windows, Mac, Linux, etc., which makes it a mobile technology for development and deployment. All leading cloud providers offer quick integration with Docker images. Sixth, collaboration and scaling. It is easy to refresh, clean up, and repair the segmented application using Docker containerization. All small processes created by Docker can be easily integrated with APIs. Thus, it saves time and money in developing high-end applications. Seventh, quick testing and rollback. The easily versioned Docker images are quick to test and can be easily rolled back. Thus, it creates a perfect environment for continuous integration and continuous deployment. Potential disadvantages of using Docker. Dockers offer multiple advantages but has a couple of potential disadvantages as well. The most probable disadvantages of using Docker, as observed by the developers, are: first, fractured container ecosystem. Not all container products come under the open source category, as multiple Docker products don't work seamlessly with others. Second, ineffective graphical applications. Docker was never designed to meet the design requirements of a graphical application. Thus, Docker requires creative strategies like X11 video forwarding to run a graphical user interface app inside the container. Third, ineffective bare metal speeds. Dockers can't run at bare metal speeds, as containers consume more resources than virtual machines. The interfacing between the host systems and containers, overlay networking, etc., are the other issues with Docker speeds. Fourth, no Omni benefits. The applications designed to run as a set of microservices gain strength from Docker. However, the multiple advantages of Docker are of no use to the other applications. Fifth, complicated persistent data storage. The data inside the container disappears when the container shuts down. Thus, it requires special data saving procedures like Docker data volumes, which is still far away from the ease of use. Key takeaways. Docker is a popular open source containerization platform. It is a necessity of modern niche developers that optimizes the power of cloud technology to generate effective applications. It simply combines the application source code with the operating system OS, libraries, and dependencies required to run codes in different coding environments. Thus, Docker comes as a toolkit that helps developers build, run, deploy, stop, and update containers with simple commands and single API automation. Docker helps developers manage containers and is a revolutionary technology. We believe that our session on Docker has made you feel a little comfortable and better understand cloud technology. You can subscribe to our YouTube channel for more details on the informative sessions on different top grossing and high-end technologies. Click on the bell icon to get the latest notifications on the recently posted updates. Hope you guys enjoyed the video on what is Docker. Please don't forget to like and share this video. For any queries, comment below and we will get right back to you. Thank you. Hi, we are back with another video on the topic, what is Kubernetes? Before we deep dive, please make sure you subscribe to Scalar's YouTube channel and don't forget to turn on the bell notification icon. If you have any doubts, feel free to drop a comment below. What is Kubernetes? Hi everyone, are you one of those who quite often hear the word Kubernetes? Well, we know everyone around you is talking about Kubernetes. And if you're the clueless one, you have jumped into the right video today. With the whole universe things to learn, it's important to kickstart the process with the essentials. So in today's session, we are going to study Kubernetes from the basics. Before diving into the topic, let's quickly have a look at our today's agenda. First, what is Kubernetes? Second, the origin of Kubernetes. Third, how does Kubernetes work? Fourth, why do you need Kubernetes? And fifth, use case of Kubernetes. So, what is Kubernetes? In technical terms, Kubernetes is a portal and open source platform for managing containerized workloads and services that facilitate declarative configuration, letting you run a distributed system resiliently with scaling of your application. Well, that's too complicated to understand. Let's simplify. Kubernetes is a container or orchestrator with respect to the software that ensures each container is positioned correctly to work together, just like the conductor manages every minute detail in the orchestra. The same way, the Kubernetes platform makes sure that the services are running smoothly in the way an app developer wants. Before we go into more details, let's understand the origin or the history of Kubernetes. Let's get started. History of Kubernetes. First introduced in June 2014, Kubernetes is an open source container initially designed and developed by Joe Beda, Bridan Burns, and Craig McLeukey. Later, they were joined by other engineers from Google, including Brian Grant and Tim Hawkin. Now the Kubernetes is maintained by the Cloud Native Computing Foundation. Over the years, The overall design and development process of Kubernetes was highly inspired by the Google Blog system. Every week, Google generates more than 2 billion container deployments powered by Bog, its internal platform. This project was originally named the Project 7 of 9, where the 7 spokes in the Kubernetes logo show its significance. One of the companies that worked with Google on this project was Red Hat, that later became the second leading contributor for the Kubernetes upstream project. Since its original release in 2014, there have been several updates in the technology. However, the latest Kubernetes version was released on 4th August 2021. Now, as we have had enough discussion about Kubernetes and its origin, it's time to introduce how it works. So, without skipping any part, keep on watching the video till the end. How does Kubernetes work? Undoubtedly, Kubernetes is one of the most prominent technologies in the modern world. It is specifically designed to make managing microservices clusters of containerized applications automated and reliable. However, beneath this easy notion is a world of complexities. Let's know about them one by one. First, cluster structure, master nodes. Within the cluster, there are different types of nodes. The very first node is known as a master node. There are primarily multiple master nodes that serve as the brains of the operations. Then comes your worker nodes or nodes. In addition to master nodes, Kubernetes has worker nodes in the charge of running the actual workloads. Both master nodes and the worker nodes together make the control plane that promotes easy functioning. Control plane or API. Every time you want to chat with the Kubernetes cluster, you would have to go through the API server. All the operations against pods are executed through the API server. Controller manager. A controller manager is a sort of a big overwatching manager that manages a bunch of processes. The controller manager is responsible for ensuring that the shared state of operator is working as expected. Scheduler. The scheduler is in charge of figuring out where the pods should run, and that's kind of a big deal. As to how the details are determined may vary based upon the characteristics of pods and the available nodes. The scheduler is responsible for watching over the given task and ensuring the node's performance. Then comes your etcd. Etcd is basically the brain of the Kubernetes. etcd is a distributed object store that acts as the database of records for the configuration and state of the entire cluster. So all of the cluster states will be stored in etcd as a key value store, and then the modifications can be made by talking to the controller manager. Moving forward, kubelet. Kubelet is the thing that actually runs the pods. Its core purpose is to enforce the directives coming from the head node and report back the actual condition of the worker load. It also updates information with the cluster. Moving forward, kube proxy. The kube proxy is responsible for managing the traffic coming into a node from the service later. It requests work to the suitable container. With this, we land on our next topic, that is the need for Kubernetes. Why do you need Kubernetes? If you're a technological person, you must have encountered Kubernetes in the past. Over the period, Kubernetes have become hugely popular to the extent that developers feel that application pipeline is outdated if they don't use Kubernetes. Let's deeply understand the various reasons why you need Kubernetes. Container orchestration. Containers are an efficient choice that enables you to package and deploy services, ensure effective resource utilization, and an incredibly lightweight in creation. But when we look into the real picture, one can end up with hundreds and thousands of containers that need to be deployed and managed safely. Don't you think the containers should be able to scale up and scale down as per the demand, provide communication, round cluster, or make them fault tolerant themselves? Well, the answer to all these is Kubernetes. These are the tools that sit on the top of containers and promote easy functioning. Great for multi-cloud adoption. With the increasing popularity of microservice architecture, there's no surprise that containers and the tools that are used to manage them have become so popular. The microservice architecture is responsible for splitting applications into smaller components with containers that can be run on various cloud environments. Better management of your applications. The breaking down of applications into smaller parts can be managed through Kubernetes, promoting easy code management and test-specific inputs and outputs. Features such as automated rollouts and self-healing effectively work the container for you. The various benefits of Kubernetes. First, Kubernetes can be used for the deployment of your services or to enable new release without downtime. Second, Kubernetes technology is portable that could be run on the public as well as a private cloud. Third, Kubernetes can be used to promote almost all needs. All you have to do is to choose a well-defined module and customize additional features as per your requirements and plugin. Fourth, one of the most appreciated features of Kubernetes is the self-healing feature, which has to be included right from the start. Fifth, another exciting feature that will soon be added to Kubernetes is self-adaption. Sixth, factors such as fault tolerance, scaling scheduling, and zero downtime adds significant value to the Kubernetes. Seventh, Kubernetes promotes the safety of confidential information and stores it safely. Eighth, Kubernetes is capable of running in a hybrid as well as an on-premise environment. Apart from these, there are many other benefits of Kubernetes, such as ease of access, service discovery, and many more that makes this technology open for more people. Now, when you have understood this need, it's time to understand when you should use it. The use cases of Kubernetes. Over the years, the adoption of Kubernetes has grown immensely from 27% in 2018 to 48% in 2019. Yes, the number is enormous, which makes it one of the widely used containers orchestration tools. Keep on watching to see what benefits does Kubernetes bring to you. First, learning Kubernetes by deploying a simple app. There are real-life examples where the power of Kubernetes can be used to deploy apps. Let us break down this through an example of better understanding. Imagine there is a creative agency developing a web page for the pharmaceutical industry. Every medicine presented on the web page will have a dedicated page with information about the medication, including the dosage, description, effects, impacts, etc. In such a scenario, the Kubernetes will come as a savior as it will efficiently manage the cluster through better resource allocation. Second, if your application uses a microservice architecture. If you're more gravitated towards the microservice architecture or looking to transition towards it, the chances are that you already use Docker, a software to containerize your applications. For such purposes, Kubernetes suits all needs. Remember, microservice is not always the best choice, but it offers excellent advantages when the microservice architecture is chosen with Kubernetes. It manages the entire working process, simplifies it, and considerably reduces the work needed to run the app. Third, lift and shift. Lift and shift refer to the recently occurring scenario since the software is now being transferred from on-premise infrastructure to cloud solutions. Let's understand the concept of lift and shift through an example. Say we have an application deployed on physical servers in a classical data center. For specific reasons, it has been decided to move it to the cloud technology to big pods in K8s. So, the shifting of applications working outside the cloud and further transferring it to the big pods in Kubernetes indicates the lift and shift methodology. Fourth, if you are suffering from slow development and deployment, there may be instances when you cannot meet the customer's demand. If yes, then Kubernetes might help you in such a scenario. Rather than employing a team of professionals wasting their time in analyzing problems, Kubernetes can effectively manage the situation. Fifth, computing power for the resource-hungry task. Recently, the Guinness World Record in computing power was broken by a Google employee who reached 31.4 trillion digits. The number is vast, which requires huge computing power. What if the Kubernetes technology manages this calculation? With Kubernetes, you will be required to write a program to perform the calculations, whereas Kubernetes will effectively handle everything else. Sixth, lower infrastructure cost. In order to ensure that your clusters always have enough resources to meet the demands of the running applications, Kubernetes uses efficient resource management that lowers the cloud infrastructure cost. Seventh, CI or CD software development cycle. Kubernetes have highly benefited from continuous integration, continuous development. Whether it's for developing the new versions for testing the releases, Kubernetes make the processes easy and manageable. Summing up, with this, we end today's session here. Now, when you have learned what Kubernetes is, how it works, and its uses, we would love to hear your views about the same in the comment section below. If you guys have any queries or questions about what we discussed just now, you can leave them below in the chat box. In today's session, we deeply discussed Kubernetes, its history, and how it works. Additionally, we also learned about why you need Kubernetes and use cases of Kubernetes. Hope you guys enjoyed the video. Please don't forget to like and share this video. For any queries, comment below and we will get right back to you. Thank you.